Okay, Dave, let's pick up where we left yesterday. So today we're going to tweak a few things what we're going to do. So yesterday we did list, create, and toggle. We still need to implement delete. But we're going to tweak a few more things here. We're going to, so I'll just get these run orders, whatever. We're going to create our own with own library. We're going to create our own library, and we're going to store the to-do list in memory. As part of creating that own library, we're going to look at a practical example where you might use classes, and then we'll see where we end up with these things here. So let's go back to source. So we still need to implement our delete one, and the delete one, it's going to be very similar to the toggle one in that we're expecting to pass an object with the ID to it. So we're going to delete. Yeah, okay, toggle that. So we're going to do delete. Say D1. All right, D1. So wait, we're not. So actually, instead of changing something, since we're deleting them, we're going to use. So this is our list. We're going to say dot filter, and it gets passed. It basically iterates through each item on the list. And then if it comes back as true, one second, I need to. Okay, set it. Close my vent over there, so it's turned into furnace. So it gets past every item, and if it returns true, the list would come back the exact same. If one of the items returns false, it's filtered out. So what we're going to say is the d1.id does not equal the item.id. So basically, if it does equal, we're going to return true, and it's going to filter out. So I think that's all we need there. Let's start our server. Yes. And let's go test this. And where did I download it? It's closed Insomnia. Okay. Local Scratchpad. Oh, good, they still have it here. So I'm actually just going to duplicate this one and call this one delete. And we're going to hit the delete endpoint. And yeah, and we pass that's what we're expecting there. So let's go back here. Somewhere on list, there's nothing there. Let's go and create two of them. We're just going to do one, and we're going to create two. We go back to list. I expect to see two of them. We see two of them. Let's go ahead and toggle number one. Go back to list. Let's see number one has been toggled. Let's go ahead and delete number one. Send it. If we go back to list, now it's gone. Anyway, so we have implemented our 4 endpoints. Now, here's the thing. This is kind of an annoying way of doing it. So what we're going to do is we're actually going to create our own server class. So we're going to create one called, coolserver.js or TS. And let's go ahead and instill a little bit of logic from over here. So we're going to want that. We're actually going to want this whole thing right here. But we're going to remove, let's remove all these for now. The final thing we're going to do is we want this. Now I'll show you how we're going to use these. So ignore those for now. Let's go ahead and create our class. So we're going to say export class cool server. Not functions. And we're going to give it a constructor. And this is so when you create a class, you give a constructor, and we're going to have you pass in a port. That'll be a number. just for fun, we're going to make a private variable that can't be accessed outside this class. We're going to call it port, be a number, and then when it comes in this dot port, because now this is referring to the specific instance of the class, equals p dot port. So that means inside of our class here, we can always access this private thing, but no one else can. So let's go ahead and we're going to create one called register post. And inside of that, we're going to have them pass a URL, and then we're going to have them pass a function. Inside that function, the function can expect to get an object that has, we'll just say the body, and that will be any. And I'm trying to think what else we'd want here. And that's all we'll do there. And I expect it to return an object of some type. We'll say let's say a JSON. No, we'll just say an object. Okay. Okay, so we're going to be doing the two things that are a little bit more complicated. Not too complicated, but and so this is what we're going to do. We're going to create another URLs, and what this is going to have, it's going to be a record of a string, which is, I guess we can do this another way. We're going to say URL, which is going to be a string, and then we're just going to have the, let's define this object, type, handler equals that. Oops. What did I do? Oh, I'm so dumb. Yeah, I had this wrong here. Yeah, thought that was a little weird. Okay. Why are we angry? Oh, we killed that. There we go. So on this object that's going to be private to the class once we instantiate it, we're going to create a map of these private URLs and the HTTP handler. And this, just for fun, we're going to say post URLs because we're registering a post one. So all this register thing is going to do, it's going to say post URLs, and we're going to do p.url. We're going to do p.function. Now, as part of the constructor, we're actually just going to start. I guess we don't need to really save the port here because we're just going to start it. No, we'll do that. This will be a little cleaner. We're going to create another private, we'll make it public, start. And all start does is it is going to create a server. So we're going to put this in here. And we're going to change how that works in a moment. And after the server is created, and just for fun, we're going to create one private start has run, so boolean equals false. And when we set this, if start has run, if it's already run, we're going to throw new error. Error. Server has already started. No, we won't throw an error. We'll just do console.warn. And we'll do nothing. We'll return. Else this dot start Start has run equals true. This is just going to keep them from calling start twice. Okay, so we're going to gather all the data here. We're going to say, just for fun, we're going to be like message pool server only supports post request. Okay, now on this one, this is where you get a little more interesting. We're going to say, this is where we're going to say, okay, if this dot post URLs request dot URL, but basically we're saying if this URL has been registered with the server, great, we're going to handle it. We're going to oh boy, here in a second, I need the so this is the body. We'll just say so this is the body text. We'll parse it for them, and then we're going to say I'm trying to remember because okay, yeah, we do stringify it. Anyway, we're gonna get the body, and then let's go. I say, well, this dot. I'll just show this thing right here. Body. So we're going to pass the body in. It's going to handle it. Cons will just say response. The response object will just say arrow. And then we are actually going to stringify the response object, and we're going to send it back. So now we can say else. Let's call this. Actually, let's kill this. This is going to be on you know what? Let's just do this because the else will handle this just fine. We'll just say method not allowed. Okay, so back to here though. So if this URL hasn't been registered, we are going to we'll just say URL not registered. Okay. So this is looking pretty good here, and we're going to, now the one thing is this is on the port, this dot port, because we want whatever we configured it to be. Okay, so we are essentially creating our own little library here. This is looking pretty good. I mean, in theory, this should work. We'll find out here in a moment. Okay, so let's go back to our server here. Now, just for fun, I'm going to rename this. This is vanilla server vanilla. Okay, we're going to copy that. And we're going to say, oh, what happened here? Right. And we're going to call this one server custom, we'll just call it using pool server. So let's go ahead and tweak this, and now we're going to, so we're going to say import, okay, so we have pool server. Now, instead of creating all this stuff, what we're going to do is we're going to say const server equals new pool server, and we're going to put it on port 3000. And we'll just say S1. Whatever, let's call it server. Rename that one for a second. So now we can begin registering our route. Server.register post, and the URL is we're going to register list, and the function is we'll say body. I guess this is let's see if this is not oh well. The handler, that's what you call it. What do you call that? No, function fn. Doing something wrong here. Dum. This is all supposed to be one object. Right there. Okay. So this is where we're going to return. So we have to deal with, so you can see with our wrapper here, I don't have to deal with parsing the data, like parsing the body. I don't have to worry about writing the application data. I don't have to worry about stringifying it. All I have to return is the data. So literally all I have to do is I'm just going to say return to-do list. Okay. Let's go ahead and register our next one. We're just going to duplicate that. We're going to call this, what are they? This, I will do create next. So create new item. All we have to do is SMP because now it's angry right now because of TypeScript. So to-do list is it's expecting it wants a to-do item, which is ID text toggled, whereas P right now it's just anything. Oh, P.body. Now, so it's a little bit angry. Actually, it's okay there. And we're just going to do P.body because what happens? P.body. Yeah, we'll just refine say new item equals P.body because okay. Now in the real world we'd want to be testing this stuff, but so. Yeah, but we're not going to test to make sure it is. We're just going to assume they're passing the right data. Okay, let's go on to the next one. So the next one is toggle, and this one is it's just still our logic from over here. First data T1. Don't need to do that anymore. T1 equals P.body. Yes, I probably should say change that. And okay. Final one is we're going to do delete. Delete, and this is going to still our thing from here. And we're just going to change this to D1. Okay, so in theory, that is our new server. Now we did all this, but we need to start it. If you recall, so remember I said server.start. So we're just going to create it, serve it, and then we'll register it after. It's fine. So let's see if this works. Okay, so no. And that's it, properties undefined. Okay, yep, I know what's going on here. So what happens is this is expecting it to be an object. And so when we're registering this, it's expecting to find the object and add a new property to it, then add a function. The problem is we actually never created a base object for it to use. So let's try that again. Oh, this is looking better. let's see our list. Nothing, no headers. I'm thinking about it. I know what the problem is. So the problem is, like, we just failed because I didn't account for something in the thing. So every time we handle something, I always parse the data. Now, if you remember back, but the list one actually doesn't have any data. So we're going to do an experiment here. And so anyway, it throws an error because you're trying to, we're just for fun, we're going to add an empty object here. And it returns fine. What we could do if we wanted to be a little bit more robust is we could change that to let. We'll just do empty object. Let's see. Whatever. And you just try catch here. Say, yeah, if this errors, we don't care, so we're going to leave that empty. Say body equals JSON.parse. So the point is, we're going to allow, and there are times when you do a try catch and it's okay. In this case, we're just going to say, yeah, if you pass some data, we'll parse it. But if not, we don't care. It's going to throw an error, but we'll catch it, and then we'll just use an empty one. So let's save that. It's kind of the process of making your code a little bit more resistant to code. So let's go no body here again, because that was our original API. And it's working. Let's go ahead and create one. We'll do number 2. Now we'll do list. And we're getting back number 2. Let's toggle number 2. Yep, it's like everything's working. Delete it. Now we should get back a list that's empty again. Great. Anyway, so you can kind of see, I mean, you just can contrast the two here. So let's go back to here. Let me make this a little smaller so it's a little easier to see. By using an abstraction, by creating our own little server, we don't need this here anymore. By using an abstraction, our own little server, you end up having a lot less code than, maybe not a lot less in this case, but overall less code. And this is just much cleaner. So now we're not actually going to use our cool little server. The point of this, the point of today's was to essentially give an example of where you might use a class and some of the functionality on it, but also to kind of help you get seeing, like, when I pull in a library, it's not like they're anything magical. You could write your own. We're going to use a server called Fastify. The point is, there's nothing magical about them. They've just spent the time to write a way more robust server than this. I mean, you saw my 1 or 2 little errors we had to troubleshoot. Believe me, if we tried to use this little server we just created for anything real, there'd be so many problems because there's so many edge cases you have to handle. So that's the reason why I use a library where someone spent more time to make a very robust one. Yeah, so that's going to be today's lesson.